Hello all, welcome back to Sri Sai Tech Edu YouTube channel. Read, Lead, Success. I've already started with the network analysis and control system videos. In this network analysis part of module 1 and module 2 is already uploaded in my channel. From this video, I am starting with the control system topic, that is from module 3 to module 5 you have control systems. Control systems module 3 we have only one chapter, that is basic concepts and representations. In this we are going to learn many of the concepts. Under this module, there is basic concepts and representation. Under this, we'll study introduction, types of control system, effects of feedback systems, modeling of mechanical system elements, electrical systems, analog systems, and block diagrams, where in that the block diagram of a closed loop system, then procedure for it, then block diagram reduction, construction of signal flow graphs, basic properties, signal flow graph algebra, construction of signal flow graph for control systems. Like this, we have many concepts under this module. First, we will see the what is control system, its introduction and types of control systems in this video. Introduction. A system is a collection of objects or components connected together to serve an objective. Or system is a combination of components that act together to perform an objective. A system means what? It is a collection of objects or components connected to do some objective or to do some work. Or a system is a combination of components that act together to perform an objective. What a system does, it is going to connect together to do some objective or a work. Mobile phone or a washing machine. Washing machine, what it does, all the components are connected in the washing machine so that it is performing washing of clothes. And like FM radio or any of the embedded system you take. Projector, what it is, all the components are connected so that it will project the image whichever it is getting. So it is its objective. So a system which will connect the components and give an objective. For an objective, we are connecting those components, means it is a system. Control system is a system in which the quantity, the output quantity is controlled by varying the input quantity. Control system, we are controlling the system. System is to do some objective. Controlling the system is what we can, in which the output quantity can be controlled by input. If you vary the input, then output also varies. Understanding? If you want to change the output, by varying the input, we can change the output. This is nothing but a control system. Now we will see types of control system. What are the types of control systems? Control systems may be classified in a number of ways depending on the purpose of classification. It is classified in number of ways, like depending on the hierarchy. Control systems may be classified as open loop control system, closed loop control system, optimal control system, adaptive control system, learning control system. Depending on the presence of human being as a part of control systems may be classified as manually controlled, automatically controlled, where humans are involved. Okay. Depending on the presence of feedback, control systems may be classified as presence of feedback or not a present. Open loop control system doesn't have any feedback, whereas closed loop control system or feedback control system has a presence of feedback. According to the main purpose of the system, control system may be classified as the main purpose of the system. Based on the main purpose, the control system are classified as position control system, velocity control system, process control system, temperature control systems, traffic control systems, etc. Like this, there are different control systems classified. In exam, if they ask types of control system for many marks, then draw this flow chart so that it will be, you will score more marks. And in the module, only some of the types are being discussed, like open loop, closed loop, and like that some control systems are only discussed. Not all control systems are discussed, not these all are not discussed. So better if they asked for classification of control system, draw this flow chart. If it is for 10 marks, 12 marks, more marks for it, even if it is for 8 marks, draw this flow chart Then we'll write some explanation. Feedback control system may be classified in a number of ways depending on the purpose of classification. The feedback control system, again they are classified into based on the purpose of classification. How? According to the method of analysis and design, control systems may be classified as linear control system and non-linear control system, depending on whether parameters of the system remain constant or vary with time. Control system may be classified time variant or time invariant. If based on the situation, if the time is varying, then it is time varying control system. If time is not varying, they are called time invariant control system. According to the types of signal used in the system, control systems may be classified. The types of signal used: continuous data or discrete data, AC control systems or DC control systems. Continuous data is like data is in the form of bits, zeros and ones. Continuous data is in the form of a sinusoidal wave, and discrete data is nothing but at discrete levels. That is nothing but either it is discrete bits like zeros and ones. Continuous data is nothing but AC signal, DC signal, like that. Okay, depending on the application, control systems may be classified as position control systems, velocity control system, process control system, traffic control systems. It is based on the application. Then depending on the number of inputs and outputs, there are many control systems like multivariable control systems, multiple input, multiple output control systems, single input, single output control systems. And depending on the number of open loop poles of the system, number of open loop pole like type 0, type 1, type 2 you have, like type 3, etc. Many systems are there. Depending on the order of differential equation used to describe system, control system may be classified as first order control system, second order control system, like that, based on the order. Depending on the type of damping, control system is classified as undamped, underdamped, critically damped, overdamped. You can write this. Then in this topic, we discuss some of the depending on hierarchy, control system may be classified as first one is open loop control system. What are open loop control system? The systems in which the output has no effect on the control action, that is on the input, are called open loop control system. Open loop is nothing but there is no feedback. If you see this diagram, reference input, actuating signal between one controller to other controlled process plant. If this is some of the system which is being controlled by the controller, then the controlled variable output, the output is not depending on the, has no effect on the control action. The output has no effect on the control action. That is on the input are called open loop control system. See, there is no something like feedback given back. If feedback is given, they are called closed loop control system. Here in open loop, there is no feedback, means the output has no effect on the control action, means this will not affect the input. So there is no feedback from the output. So they are called they are called open loop control system. Output has no effect on the control action, that is the input. Output has no effect on the input, are called open loop control system. In other words, in an open loop control system, the output is neither measured nor fed back for the comparison with the input. Nothing but the output is not fed back like this. It is not fed back. So not fed back and not compared with the input. So it is called open loop control system. In other words, any control system that operates on time basis is open loop. This operates on the time basis. Open loop control systems can be used in practice only if the relationship between the input and output is known, and if they are neither internal nor external disturbances. Open loop, they are used only if the relationship between input and output is known. Only if the input and output relationship is known, we will use open loop control systems. Next, what we have, closed loop control system. What is closed loop control system? In closed loop control system is nothing but feedback control systems are often referred to as closed loop control system. As you can see the difference between the previous and this diagram, there is an output to input, there is something going back, there is feedback signal, feedback path elements are going back to change the input function based on the output. So in practice, the terms closed loop control, feedback control are used interchangeably. So it is also called closed loop control system or feedback control system. Then what you have? In a closed loop control system, the actuating error signal, which is the difference between the input and signal and the feedback signal, which may be the output signal itself or a function of output signal and its of system derivatives and auto integrals, is fed to the controller so as to reduce the error. This is very important. Reduce the error and bring the output to a desired value. What is the benefit of feedback rather than the open loop control systems? See, this is same anyway. Controller and the actuating signal plant, controller plant, actually everything is same. The output is now fed back. The feedback elements, the output which we got, it is going to be fed back. Signal, if this is minus or this is plus, the reference input is this. Error will be detected by this summing point. Error will be detected in such a way that reference input Ri minus feedback input, if you take as Fi, will be the error signal. E will be the error signal. You think this E is the error signal. Error detector will detect the error signal of Ri minus feedback. This is Fi and this is Ri. So this will, Ri is plus and Fi is minus. So if you subtract that, what we get? The error signal. That error, which is that signal is there, no, that will be given to the controller so that the output you will get a correct value. This feedback, how it helps is the output which it is coming, no, it is going to see the compare with the reference input, the input, and compares and finds the error. That error signal again, if it is sent to controller, so that this will reduce the error and bring the output to a desired correct value. Understanding? This is what the main advantage of closed loop control system. A system that maintains a prescribed relationship between output and the reference input by comparing them and using the difference as means of control is called the feedback control system. Examples of open loop vs closed loop control system. Here I have compared both open loop and closed loop control systems with the examples so that it will be easy for you also to understand what is open loop and what is closed loop with the same example. Open loop control system, if the example is traffic control system. Traffic control by means of traffic signals operated on a time basis constitute the open loop control system. The sequence of control signals is based on a time slot given for each signal but not measure the density of traffic before giving the signals. It gives the signals in sequence as per the setting irrespective of the actual traffic. What is open loop control system in case of traffic control system is, for example, you see the traffic signals based on the timing, it is going to change its red, yellow and green based on the timing. So that is what they are telling, it is on the time basis. Based on that, if 10 minutes is allotted, after 10 minutes the other line of the traffic signal will be allowed. Based on that, the color will be changed. But here in the open loop control system, it is not going to see the traffic density. Traffic density is nothing but it will not going to see which side the traffic is more, so that we leave them. It is not like that. In closed loop control system, the signals are based on the density of traffic. Other everything is same. The density of the traffic is checked. In open loop control system, no density of traffic. It is not going to check in which lane or which road side the more traffic is there, so that we will leave that line. It is not going to check. Based on the timing, it is going to change continuously red, white, yellow, green. But in closed loop control system, it is going to check in which area or which line the traffic is more. It is going to leave that line first. See, in a closed loop control system, density of the traffic is measured on all sides and information fed to the computer. The timing of control signals are decided by the computer based on the density. Based on the density of the traffic, the control signals will be decided. For example, if there is a 4-lane road. In that 4-lane, 1-lane road is very traffic. So that lane respective signal will give being green and other all will be red. That is what closed loop control system. But open loop control system, it is not going to check those all things. Based on the time set by the traffic controller, it is going to change red, yellow, green. It is not going to check the density, which side more, which side less, nothing. Same way we see for room heating system. A room heater without any temperature sensing device is an example of open loop control system. It is not going to sense any temperature without that it is going to room heat. In this, an electric furnace is used to heat the room. The output is the desired room temperature. The temperature of the room is risen by the heat generated by the heating element. The output temperature depends on the time during which the supply to the heater remains on. Whatever may be the room temperature, after the set time the heater will be off. Whatever may be the room temperature, after the set time the heater will be off. See, in this open loop control system, based on the timing, it is going to on and off. Based on that same time basis only. It is not going to check whether the room temperature is correct or no. Nothing it is going to sense. It will just on and off, on and off, on and off based on the time setted by it. Like if it is for 1 hour, keep on, and after 10 minutes, keep off. It is going to do accordingly. But in closed loop control system, it is not that case. In closed loop control system, the system becomes a closed loop system if a thermostat is provided to measure actual temperature and the actual temperature is compared to the reference, and then the difference is used to control the timing for which the heater is on. In the closed loop control system, what it happens is it is going to measure the actual temperature and actual temperature and the so the thermostat is provided to measure the actual temperature, and the actual temperature is compared with the reference temperature. It is going to compare the actual temperature to the reference temperature so that it will provide the correct temperature to the room and keep the heater on whenever it is required. See, if you want heater at that moment but it is off, no use, right? But if it is going to check for us how the room temperature is, whether it is good or bad. If it is good, okay, fine. If it is not bad, it is going to on based on that. So it is closed loop control system. It is not time based. Whereas again, washing machine, open loop control system is a time based. A washing machine without any cleanliness measuring system is an example of open loop control system. In this, soaking, washing, rinsing in the washer operate on the time basis. The machine on time is set based on the same calculation. Once set on time is over, the machine will automatically stop, whatever may be the level of cleanliness. In open loop control system, washing machine, what we want from washing machine, it need to clean good and should give a good very good clothes with all dirt removed. That is what we require. No, but in open loop control system, it is not going to check the cleanliness level of the clothes. It just soaks, washes, rinses. That's it. Based on the time basis, it is going to do all the steps and it is going to give the clothes out. Whether it may be good, neatly cleaned or no, cleanliness level is not checked. Whereas in closed loop control system, this can be a closed loop control system if the level of cleanliness can be measured and compared with the desired cleanliness reference input, and that difference is used to control the washing time of the machine. Here, it is going to check the cleanliness of the clothes. If the cleanliness of the clothes is not good yet, so it is going to increase the time and clean once again. But in open loop control system, based on the timing, it is going to stop, on, stop, on, stop. But in closed loop control system, it is not the case. In closed loop control system, if there is some cleanliness problem or cleanliness is not proper with the cloth, then it is going to increase the time and clean the clothes. Understanding? These are the differences based on the example open loop and closed loop control systems. Now we will see the advantages and disadvantages of open loop and closed loop control systems in a summarized way. These summarized, see, this one and the examples which I told in the previous slide can be written as a differences for open loop and closed loop control system if asked. Those examples also can be written and these points also can be written for the difference between open loop and closed loop control system. First we will see the open loop systems are simple and economical. As it is easy construction, open loop control system are simple and economical. They consume less power. As it is on the time basis, it is not going to take more time. So it is going to consume less power. And third, the open loop systems are easier to construct because of less number of components required. It requires only less number of components. And fourth point, stability is not a major problem in open loop control systems. Generally, the open loop systems are stable. The open loop systems are inaccurate and unreliable. They are inaccurate because they are not going to check the cleanliness, or either it is going to check the density of the traffic, or it is not going to check the heating of the room before on and off. Based on the time basis, it is going to do its work. The changes in the output due to external disturbances are not corrected automatically, so they are more sensitive to noise and other disturbances. If there is any external disturbance also, it is not going to correct open control system. The same opposite will be the closed loop control system. If you see, the closed loop are complex and costlier. Here it is simple and economical, but it is complex and costlier. They consume more power. Then the closure system are not easy to construct because of more number of components required. It is less number, more number of components. Here stability is not a major problem, but here assembly is a major problem because more care need to be taken, as it is a stable, needed to design a stable closed loop system. Here it is stable anyway, but here we need to take the take care of the stability. The open loop systems are inaccurate and unreliable, but in closed loop control systems, they are accurate and more reliable. Why? Because it is going to check the exactness of the cleanliness or traffic density, anything maybe. It is going to check the exactness or accuracy is major important in closed loop control systems. The changes in the output due to external disturbances are corrected automatically. Here it is not corrected automatically, here they are corrected automatically. So they are less sensitive to noise and other disturbances. So they are less sensitive to noise. Other 2 points of closed loop control system are the feedback reduces overall gain of the system. The feedback what we are giving in the closed loop control system, right, from output to input, it will reduce the overall gain of the system. Okay. The feedback in a closed loop system may lead to oscillatory response because it may overcorrect errors, thus causing oscillations of constant or changing amplitude. There are some disadvantages and advantages in both open loop and closed loop control systems. Based on the situation and the requirement, they are used. Now we will see one more difference of linear versus non-linear control systems. We have seen in one of the classification, right? There is a linear and non-linear control systems. We will see that based on the differences. I have to in textbook. In textbook, it is in the form of theory, lots of theory. I made it simple by giving in the form of features, different features and the differences. So it will be easy for you. They are going to ask in the form of differences only. If they don't ask in the form of differences also, for example, they ask explain linear co-control system, non-linear, then write linear control system these points and non-linear control systems these points. Understanding. If they ask in difference form, state the difference between linear and non-linear, write in the form of table. If they ask separately, explain linear control system, write these points separately. And if they ask non-linear control system, write these points separately. Understanding? So first we will see the differences between them both. Linear control systems. Definition. A system is said to be linear if the principle of superposition applies. And physical systems are non-linear to some extent. Non-linear control system, physical system are non-linear to some extent, and the principle of superposition is not applied. Just try to opposite to this. Then superposition. The response produced by the simultaneous application of two different forcing functions is equal to the sum of two individual responses. Linear. Linear is nothing but the response produced by the simultaneous application of two different forcing functions. If there are two different forcing functions like this, like 1, 2, then the two different forcing function is equals to the sum of the two individual responses, nothing but 1 plus 2. That is equals to, if you take something as z, that equals to first function and second function. Adding them both will get the linear control system. Whereas non-linear control system, when the magnitude of signals extend beyond the range of linear operation, the system should no longer be considered linear. Then analysis methods. Linear feedback control systems are idealized models fabricated for simplicity of analysis and design. They are idealized models fabricated for simplicity and analysis and design. Non-linear systems are usually treated mathematically, and there are no general methods available for solving a wide class of non-linear control systems. Common non-linearities. Ideally, linear systems do not have any non-linearities. Common non-linearity affects saturation, backlash, dead play, non-linear spinning characteristics, non-linear friction, force or torque. Okay. Then purpose of non-linearity. Linear systems are used for easier analysis and control. And purpose of nonlinearity is nonlinear characteristics are sometimes intentionally introduced to improve performance or provide effective control. Here there is no purpose of adding a nonlinearity. Linear systems are used for easier analysis anyways. So nonlinearity is not required. But here nonlinearity is added sometimes to improve performance or performance effect control. Example in application for linear control system is there exists a wealth of analytical and graphical techniques for design and analysis for linear systems. To achieve minimum time control on-off type controller is used in many missile or spacecraft control systems. So these are the differences between the linear and non-linear control systems. See this left side column, if you want you can write. Why? Because this is what I created features. If you want you can write. These two sides is the difference. If you want to mention the feature and write exactly for that feature, you can write like that. Okay, these are the differences between linear control and non-linear control system. Then we have time invariant versus time varying control system. Time invariant, as I said, time invariant is nothing but time is going to vary. Time varying is nothing but time is going to vary. Time invariant is nothing but time is not going to vary in the control system. What are the major differences? There are some differences. When the parameters of a control system are stationary with respect to time during the operation of the system is called time. Correct this, it is not a rhyme, it is time invariant system. Understanding? It is time invariant system. It is stationary. The control system is stationary during the operation of the system with respect to time. So it is time invariant. Time varying is nothing but if the parameters of the control system vary with respect to time during the operation of the system is called time varying. Nothing but when a control system is working, if there is a change in the parameters, then it is called with respect to time, then it is time varying. If it is not changing, if the parameters are not changing with respective time or it is stationary, so it is called time invariant. Examples of time invariant is nothing but what? Thermostats, traffic lights, elevator control, water tank level control. If you see thermostats, they are time invariant. Thermostat is going to sense the temperature. Traffic lights, as I said, traffic lights, it is nothing but based on the time it is going to change the signals. Elevator control, if you see elevator control, it is going to stop after some time if no one is there. When it is going to start when it senses some persons, or it is going to move continuously. Water tank level control. Water tank level control also, when it reaches the level of the water, it is going to give us some buzzer or something. So based on the timing, it is stationary. It is not going to change any of the system's operation until and unless that level is reached. Understanding? Here examples of time varying are the winding resistance of an electric motor will vary when the motor is first being excited and its temperature is rising. The winding resistance of an electric motor will vary when the motor is first being excited and its temperature is rising. As the temperature is rising, the winding resistance of the electric motor will vary. Based on the time, it is varying. Time is varying. Okay, now a guided missile control system in which the mass of the missile decreases as the fuel on board is being consumed during flight. Guided missile control system in which mass of the missile decreases as the fuel on the board is being consumed during flight. Based on the time, the some of the parameters are either increasing or decreasing or changing in the control system based on the time. So their time varies. You can write these examples. You need to remember these examples, write the definition. Then analysis and design of linear time invariant systems are usually simple. Analysis and design of linear time varying systems are usually more complex. Analysis and designing linear time invariant systems are usually simple systems. Then analysis and designing of linear time varying, as they are varying continuously, it is much more complex. See, if there is continuously changing based on the time, it is much more complex to design an analysis. No, but if it is stationary time invariant systems, then analysis and designing is simple. Understanding? Continuous data and discrete data control systems. What is continuous data control systems? A continuous data control system is one in which the signals at various parts of the system are all functions of the continuous time variable. Continuous data control system is nothing but the signals are all functions of the continuous time variable. Discrete data control systems differ from the continuous data control system in that signals at one or more points of the system are in the form of either a pulse train or a digital code. Understanding? The signals may be further classified as AC or DC. Usually discrete data control systems are subdivided into simple data control system and digital control systems. We'll see now what is AC and DC. AC is what AC control system usually means that signals in the system are modulated by some form of modulation scheme. DC is nothing but simply implies that signals are unmodulated but they are still AC signals according to the conventional definition. You need to remember this AC DCs. Then write this sample data control system and digital control system. What is sample data control system? Refer to a more general class of discrete data control systems in which the signal are in the form of pulsed data. Right? Digital control system refers to the use of a digital computer or controller in the system so that the signals are digitally coded such that in the binary code. So, need to write the definition of continuous and discrete and how it is classified. The classified definitions: AC, what is DC, what is sample data, and what is digital control system. That's it. That is the difference between continuous data and discrete data control systems. By this, in this video, what we have completed: introduction, we have seen what is control system, then types of control system was also seen. So I'll stop the video till here. In the next video, we'll see the next topic, that is effects of feedback systems. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.